Dear Heavenly Father, we just thank you for this day, Lord. Thank you for the blessings you've given us. Thank you for the students here. I just pray you may help us in this class, Lord. I just pray you may guide and lead in everything we do. I just pray you may be with the ones, be with Grace, Lord, as they're going to the funeral today. Just be with that family there. Just pray guide and lead in everything we do. In Jesus' name, amen. All right, anybody have any questions in your homework?
Did you ever test?
I think so.
Did you ever what?
Tests.
I do
Oh,
have
or
a
tests, how we talk.
You do
Okay.
or don't?
I do.
You do.
We do, you do, I do, we all do. I knew. You could.
Number 29. I thought I had it, but then the answer is so different, and I was like, I don't know what I did wrong.
The f of x equals cosine x plus 3x.
Is that? Maybe I did the wrong problem.
Am I on the wrong page?
Page.
I'm on the wrong page. Sorry.
146.
29. For equations of, find equations for the lines that are tangent and normal to the curve y equals square root of 2 cosine x at the point 5 or 4, 1. y equals square root of 2 cosine x at the point 5 or 4, 1. So to take the derivative, which is negative square root of 2 sine x.
Oh, okay.
Correct?
Yeah, I forgot to carry the, or the square root of 2. I could,
Put pi over 4 in, sine of pi over 4.
square root of 2 over 2.
Which that's going to equal
1. Negative 1, sorry.
negative 1. Y minus 1 equals negative 1 times x minus pi over 4. Y equals negative x plus pi over 4 plus 1.
Okay, that's why.
For 17, the jerk is the derivative of the acceleration.
Correct.
Okay.
Yep. Fourth derivative.
Can you do number 5?
4 minus x squared sine x. Find the derivative, right?
Mm-hmm.
Negative x squared sine x is a product, correct? So you must use a product rule.
Darn it.
So the first, derivative of the second,
Okay.
plus the second, derivative of the first. That's going to be, let's take out a negative x. So that would be x cosine x plus 2 sine x.
Wait. Oh. But how come?
Derivative of 4 would just be what?
0.
0.
Because the x.
The negative
is
2x.
What?
Oh, wait a minute, I forgot the x, didn't I? No, I didn't, I took the x out, sorry. I took the x out. And you didn't have to take the x out, you could have left it at negative x squared cosine x minus 2x sine x. Any other questions?
13C. What do you say for that?
Describe the motion of the body. All right, you want to say the starting point. You want to know where it goes to, where it comes back to, where it goes to, directions, and so on. So if we're dealing with, you said number 13?
Yeah.
3 sine t. So velocity equals 3 cosine t. Alright, where is the velocity equal 0? Where's cosine t equal 0?
Pi and pi over 2.
Oh, pi over 2 and 3 pi over 2.
Or, yeah, pi over 2.
Alright, where's the position starting at?
2.
Put 0 in for sine.
Oh,
Sine of 0 is? You were right, starts at 2.
oh,
You put 0 in, sine of 0 is 0. Times 3 is 0. Plus 2 is 2. Alright, which direction does it move?
so the right,
Put 0 in for the velocity. What's the cosine of 0?
1,
Times 3 is,
3,
so it moves right. Two.
pi.
How do you know it's 5?
Because you move right 3 or?
We're looking for where it moves to, so what is its next position? How do you know? How do you figure out 5?
Just added 3 and 2.
No. Yes, but no. Why did you add 3 and 2?
Because you start at 2 and then the velocity is 3.
Well, here's your particle. Where's my good marker? When does it change directions?
When it goes negative.
Anybody, where does this change directions?
When it crosses the x-axis.
But when does the particle change directions?
Isn't it when it stop, begins to stop?
When it stops. When did it stop?
At 3.
Is that what we did this for?
Oh, yeah.
Find out when it stopped? When the velocity was
Pi
0?
over
Pi over 2. So I want to find out where the particle is at pi over 2. So I plug it into my position equation. Sine of pi over 2 is what?
0 or 1.
1. 1 times 3 is what?
3.
Plus 2. That's why you added 3 and 2. To get 5.
So I just got lucky putting.
Then I move left 2. When does it stop again?
3 pi over 2.
So I'm going to put, where is my particle at 3 pi over 2? Put 3 pi over 2 in.
Negative 1.
Times 3.
Or negative 3.
Plus 2.
Negative 1.
So particle starts at 2, moves right to 5, then left to -1, then oscillates between 5 and -1. So that's how you describe the motion of the body.
Okay.
I didn't think there was anything else that they asked you to do. 3.5. Yes. Number was that? That was number 13. Alright, we're gonna wrong one. That's pre-calculus. Thinking they wanted something else there, that description, but I'm not sure. Just try. No, that's what they want. So that. Any other questions?
20, wait, is that the one?
I have no idea, son.
Yes, 25.
Assuming that the derivative sine x equals cosine x and the derivative cosine x equals negative sine x, prove each of the following. Are you doing there in A and B exactly what we did in class yesterday? I showed
It
you
is?
how to.
That's what it means by proving?
Mhm.
Okay. Well, okay. I wasn't sure. Then.
Not like you live with this teacher.
Home is for
Now I
home.
can take advantage to
You wanna live with him? I'll trade places. Just kidding.
Connor,
Yes.
he probably has an answer key for the tests at home, so.
If he digs his hole deeper
Yep.
and deeper and deeper from
Then I
today.
shovel the dirt right back in on top.
37. How do you find the value?
Is there a value of b that will make
different
g of x plus b differentiable at x equals 0? What's time we've done this before?
No, it's not. I can feel it in my bones. It's not.
What?
Nothing.
What does the function equal at 0?
0. Wait, no, b. I don't know. What does it equal at? Oh, wait. I'm not sure.
Well, look at your function. What function are you gonna deal with when x equals 0?
Cosine x?
Cosine x. And what does cosine x equal when x equals 0?
So 1?
1. So is there a value for b that will make x plus b equals 1 when x equals 0?
Oh. Yes.
Yes. Which is
1.
1. Next question is it differentiable at x equals 0?
Yes. No, it isn't. I don't think it isn't. Wait, I do think it isn't.
So you have no idea.
Kinda. Well, it's either has to be
What's the again, your right hand limit and your left hand limits must be the same, right?
yes.
And it must equal the same, correct?
Mm-hmm.
So when we talk about right hand limits and left hand limits, what are we talking about?
So
Why?
why?
No, if we're talking about
X
right
and
hand
Y.
limits, left hand limits, whoops, what are we talking about?
And
What have we been talking about for the last 2 months?
Derivative.
Derivative,
Ah.
right? What's your left hand derivative?
That would be sine x, right?
No.
No, because it.
What else?
Oh wait,
Right-
no,
What else?
never
Right
mind.
hand derivative?
You said
No, I was
It's a
thinking.
left-hand derivative.
I was thinking from a perspective, a different perspective. That would be 1 b 1 plus b. Wait, no, 2. If you take the derivative of x plus b,
well, b is always going to be 0 because b is a number.
So the limit,
but b is a number.
h approaches 0,
Since when did b become a
Of
number?
f
B
of
is a
x
letter.
plus
B
h.
is a letter.
Symbolizes
plus f of x
or represents
over h. The limit, as h approaches 0, of x plus h plus 1 plus, well, what's f of x? When I put 0 in, when it's equal to 0, which function am I going to use? The x plus 1 or the sine x? The sine x.
Wait,
Or the cosine x, rather.
Yeah.
What's cosine 0?
1.
I'm sorry, this not should be plus, this should be minus. Minus 1 over h. So the limit, as h approaches 0, of, again, this is going to be x plus h over h. What did I do wrong here?
So wouldn't it just not be differentiable?
Well, you need to show it. You need to show that the right-hand limit does not equal the left-hand limit.
Oh, so that not working out doesn't show that it's,
It's supposed to work out, I did something wrong.
oh.
My function is x plus 1. And my value is at 0. So this would be 0. Okay, this would be 0. So that would be. So my left-hand limit is 1. What's my right-hand limit? Cosine x. Derivative of cosine x is
Negative sine,
negative sine x. What is sine of 0?
0.
0. So my right-hand limit is 0. So my left-hand limit is 1. My right-hand limit is 0. So therefore my derivative is the same on both sides. No. So therefore it's not differentiable, but it is continuous. Because that's basically what it looks like.
It looks like this.
It's not exactly a cusp. There's my left hand. Oops, I'm sorry, I did it the wrong way. Cosine's on the right hand side, right?
Yes.
So there's my cosine, and x plus 1 is on the left side.
Yes.
So it's not exactly a cusp. It's more of a corner than a cusp.
Hmm.
So it would not be differentiable there. So yes, there is a value that makes it continuous, and that is 1. And that's what we did. We figured out what is the cosine at 0. It was 1. So x plus b has to equal 1 when x equals 0. So b has to equal 1. Okay? So that's my function. Now I get to determine, all right, is it differentiable there? Is the right-hand limit and the left-hand limit the same? And the answer is no, it's not.
So then wouldn't it not look like that?
Was that?
So then wouldn't it not look like that if the right hand and the left hand is not the same?
Well, remember, we're not necessarily talking about just limits as x approaches 0. We're looking at the derivative formula, the right hand and the left hand.
Oh, so we're looking at like the graph of the derivative, and then.
Well, we're not looking at the graph of the derivative. We're just looking at the graph of the function. And remember, if we have a corner, if we had a cusp, if we had a vertical tangent, if we have a discontinuity, infinite discontinuity, then it's not differentiable. It may be continuous. Right? Yeah, the left-hand limit and the right-hand limit, they're both approaching 1 as I approach 0. But again, I'm not approaching 0, h is approaching 0. Because we're going to use the derivative. We want to know what the left-hand derivative is and the right-hand derivative. They must match. Okay. Any other questions?
How do you find the estimation in 41A? Or use the spec to estimate sine?
21a,
Yeah, at 41A.
41a. Continuation of 40. This is the graph of the function y equals sine x, close to the origin. Since sine x is differentiable, this graph resembles a line. Find the equation for the line. What's the equation of the line?
Y equals X.
Y equals X. Everybody agree?
Yes.
Alright, so for values of X close to 0, the linear equation found in exercise 40 gives a good approximation of sine X. Use this fact to estimate sine of 0.12. Number 40, what did we say the equation of that line was?
Y equals X.
Y equals X. What does that mean?
That means Y and X are the same.
Whatever X is, that's what Y is. So therefore, if this is a good approximation of the graph sine X, when X is close to 0, what is my estimation of sine of 0.12?
That they
What did we just say? What was the equation?
Y equals X.
Y equals X. What does X equal here?
0.12.
So therefore, what does
Y.
Y equal here?
0.12.
0.12. There's my estimation. Then they say, find sine of 0.12 with a calculator. All right, you're going to take your calculator, put it in radians, do sine of 0.12, and what's my answer?
0.1197 other numbers.
So if we round it off in the hundreds place, what would I get?
0.12.
0.12.
Oh.
It's not like he doesn't live with his teacher. All right, another question. We good? All right, pass those forward, please.
Hey, it's much
I only did like half of it, so I think I'll get better credit
All right,
tomorrow. Or,
Monday.
I'll try to finish it in gym today.
All right, so today we want to talk about the chain rule for a little bit. We'll talk about the chain rule for 2 or 3 days. The chain rule is a very important concept to understand. So we'll introduce it today, and we'll see how far we get.
The chain.
So the chain rule, I try to relate this to the chain gang. All right, if you have a chain gang, that means what?
A chain game?
Gang, G-A-N-G. Ever hear the word
Gang.
chain gang?
Oh,
Yeah.
okay. No,
Is
I
that
don't
American?
think
Is
I've
that American?
What's that?
Is that American?
Yes.
Okay.
All right, so it usually applies to prisoners that are out working, and they're usually working in a line, in a chain gang. And so what one does, the other one follows up behind it, and follows up behind it, and follows up behind it. They're all kind of connected together with a chain. The chain rule is basically the same thing. We're going to basically use our unit analysis. We learned how to use unit analysis back in a lot of my classes.
Back in a lot of my classes. Back then.
Not me.
No, but we learned unit analysis in physical science, we learned unit analysis in chemistry, we learned unit analysis in my algebra class. All right, we use unit analysis all the time. Whereas when we have this group, whatever's on the top cancels out with the same thing on the bottom.
Oh, that's
all
unit
you
analysis?
know.
That's unit analysis, yes.
Oh, I didn't know that was.
I like
Okay.
those.
So basically the conversion stuff what
Yeah.
we do.
So say for instance, if we have dy over dx times dx over dv, all right, we use basically unit analysis because what happens? What happens to the dx's?
So you cross it out.
They cancel out. And so I'm left with dy over dv. Well, dy over dx represents what? What does that illustrate? What does that
Derivative.
represent? Derivative of what?
Of the
Of
equation.
function.
Of y in respects to what?
X.
X. And then dx over dv represents what?
The
Oh, the
derivative.
derivative.
The derivative of x in respects to
V.
v. And this illustration shows that I'm going to take the two derivatives and I'm going to multiply them together because of the chain rule. So we want to learn how to apply that. We use the chain rule when we usually have composites, a function within a function. So let's look at an example. Cosine of t squared plus 1. Right? So basically what I'm going to do, I'm going to split this up, and we learned back in some of our other classes that how to decompose a composition. So I want y equals cosine x, and x equals t squared plus 1. So I have decomposed the composition. My goal here is to find dy over dt. I want the derivative of this function, and I have a variable of t. So that's my goal. I want dy over dt. So if I take the derivative of this part, that's going to be dy over dx, which is negative sine x. If I take the derivative of this part, that's going to be dx over dt, which is 2t. But I want dy over dt. Well, if I take a look at these two here, these two parts here, how do I get dy over dt from dy over dx and dx over dt? You multiply them. My property of equality, multiplication of property of equality, if I multiply equals together, it doesn't change the equation any. So here on the left side, I multiply equals here, so I multiply equals here. So that, therefore, the dx is canceled out. I get dy over dt, which is what I wanted, to be negative 2t sine of x. But again, here I want t involved, not x. So I take my x and substitute it back in. Negative 2t sine of t squared plus 1.
That's interesting.
And I'm connecting things together. I can connect as many as I want. Just like our unit analysis in chemistry, we have these big, long unit analysis connecting different conversion factors together. We can do the same thing here with as many as we want. We probably won't have more than 3 to connect together. But that is what we're talking about when we're talking about the chain rule. Being able to find the derivative of a composition. We know how to find derivatives of just compound, or derivatives of functions with one variable, but when we have a composition of functions, all right, that's a little bit different. And this is where we're really starting to get into the derivative aspect of taking derivatives. Now, look what happened here. I took the derivative of the function, which is the main function, and multiplied it by the derivative of my composite, whatever was in the inside. And I don't want to have to do this every time to be able to look at this. I want to think of the principle. Derivative of the function times the derivative of the composition. Derivative of the outside times the derivative of the inside. Is how we're going to do that. Let's look at another example. Find one to do here. All right, here we go. So y equals sine to the 5th of x. Well, what does that mean? That means this is the same thing as y equals sine of x to the 5th power. Those both equations there are synonymous. They are the same. So I have a composition here. I have 2 different functions. Okay, so what is my main function?
Y equals x to the fifth.
X to the fifth. But I wouldn't use x, I already have x. I would say y equals u to the fifth.
Doesn't matter what variable I use.
Not really. We're going to learn what is called u substitution a little bit. So a lot of times they use u. Therefore, what is u?
Sin x.
Sin x. So I have decomposed the composition. Now I can take the derivative. What's the derivative of this? dy over du equals
Sorry, 5u to the fourth.
5u to the fourth. And what's the derivative of this? du over dx equals
Cosine x.
cosine x. I want dy over dx. Well, how do I get dy over dx from these two functions?
Multiply them.
Multiply them, so I get the du's to cancel out. So I'm going to multiply these. 5u to the fourth times cosine x. Well, I don't want u anymore. I want to make sure I have the same variable because I'm looking for dy over dx. U has nothing to do with that, so I'm going to take the u and substitute it back in. What was my u? Sine x. So that's going to be 5 sine of to the fourth x cosine x is my function. Let's look at another example. Let's look at r equals 2 theta square root of secant theta. Well, here we have a composition and a product. So you have to be careful here. So what's my composition? What's my inside function?
Your
Secant.
inside function?
Mm-hmm.
Secant theta.
Secant theta. What's my outside function?
2 theta times square root of x, or u.
Oops.
Yeah, u.
Oh,
I can use u to the 1/2, right?
Well,
Square root is x1 and 1/2.
yeah. Would you have to put them in parentheses, or it doesn't matter?
Doesn't matter.
Because if we're multiplying them together, never mind. That doesn't make sense.
Right, but I have to get rid of that theta somehow. This may not be the direction I want to go. I may want to do. I know what to do. Alright, so we're going to say u equals theta. V equals secant u.
Wouldn't we have to pick another variable?
And r equals 2
I mean,
u v to the 1/2. Still not working out right. I need the r to have just one variable. r to just be one variable here.
So what would we be finding, what would the derivative be that we're finding? Are we trying to find?
We need dr d theta.
Okay,
Dr d theta.
so then shouldn't it be? No.
Alright, so let's try and go back and use the product rule here first. Alright? So let's go dr over d theta equals 2 theta times d over d theta of square root of secant. Now let's do this differently. Alright, so basically what we're gonna do, we're just gonna take, okay, my u equals secant theta, alright, and my function v equals u to the 1/2. So I'm gonna do that first. Alright, then I'm gonna have the derivative of this, because I'm gonna use the product rule. Here's my first, and here's my second. First times the derivative of the second, plus the second times the derivative of the first. But I need to know what the derivative of the second is. So here's my derivative of the second. dv over du equals 1/2 u to the
Negative 1/2.
-1/2 du over d theta equals
Cosine theta?
secant.
Oh, secant,
Tangent times secant.
What I'm going to do with those two,
Multiply them and cancel out.
I'm going to multiply them, and then I can use that derivative to do my product rule. And we'll look at that more on Monday.
can we finish just one more?
Yes, we'll finish this on Monday. So ask me again, we'll finish this on Monday. What I want you to do this weekend though, I want you to go back to page 146 and do the other odds.
Okay, I have a question.
Alright, so you're working on page 146, 3 through 43, every other odd.
Okay.
3 through 43, every other odd. Okay?